Hey, hi class. How are you guys? We are on a new lesson 9-3 today. I believe that you have been assigned some videos to watch yesterday, and I hope you have had a chance to watch those. Today I'm going to teach you how to do the questions one by one. There are 4 types of questions. So here you can see the first one, example 1. Okay, and then there's example 2. And then on the next page, we'll have 3 and 4. So I will go through them one by one. Okay, first let's look at the first one. It's on the constant rate of change. Okay, so these questions are relatively easy. The one thing I really want to point out though is that at the end, what they want you to calculate is the unit change. Okay, that's the constant rate of change, and I'll show that what that means in a minute. Okay, so let's take a look at these questions. These questions are from your book. These are the guided practice questions. Okay, so these are all from this page. Okay, right here, guided practice. And I will do all of these questions, all 6 of these, to show you how to do the 4 types of questions. So here's the first one. Find the constant rate of change, okay, when you're given a table. So here's a table. There are 2 types of quantities. One is the number of items, and one is the cost. Okay, so the cost is in dollars. So what is the change from 5 to 10? 5. And then the next one, also we're increasing by 5, increasing by 5. Okay. Here we have an increasing cost of $12, $12, $12. Okay, from here to here. So the change, what they want you to figure out is the change in the cost over the change in items. So even though the items is listed first, this is like our x, and this is like our y. The rate of change is always the change in the y over the change in the x. Okay, this symbol, this triangle here, stands for change in. Okay, change in. Okay, so the slope or the rate of change is always the change in the y over the change in the x. So we're going to write down the change in the cost, which is $12. Right, $12, okay, for every 5 items. And then from that, we can calculate the units. So how much change for 1 item? Okay, you always want to find out what is the change for 1 item. So to do that, you take 12 divided by 5. And you will get $2.40 is 1 item. That is your answer. Let's look at another question. Changing time, 2. I think it's measured in, let's see, seconds or minutes. Let's see what the question asks for. It's in minutes. Okay, so this one is in minutes. So we can see the change is 2 minutes. Okay, between intervals. And then the change in altitude was measured in feet. So the change in altitude is minus 40, not 40, but a decrease. So it's a minus 40. Minus 40, minus 40. So the rate of change is always going to be the change this one over this one. Okay? Don't ever use this one and put it over this one. It's this over that. The y over the x. So we will have negative 40 feet for every 2 minutes. That's my constant rate of change. What is that per minute? Negative 20 feet. every minute. That is the unit rate of change. Okay, the unit change. Okay, so we always want to, this will be a correct answer, but this is the answer that really tells you what is the constant rate. Always over 1, okay? Over 1 of this, the x factor. All right, let's take a look at the second type of question. It says, find the constant rate of change for each linear function and interpret its meaning. So we're going to look at this graph. In this graph, we have a y-axis that stands for the height of plants in inches, and the x-axis that shows you the number of weeks. Okay, so I think this is, and it's called growth of plants. So this is a graph showing you how quickly your plant grows. So at the beginning of your growth, your plant was at 3 inches. So that may be just the thing that you planted. In 1 week, it grows a little bit more. That looks like half an inch. In 2 weeks, it reaches 4 inches. So in 2 weeks, it has grown by 1 inch. So if you have that, okay, so this is number 3. So what we want to know is, what is the change in the height, okay, in inches over the change in weeks. Okay, and I saw that what we just saw with the 2 clear points that you can find on this thing, I can see that the change in the y was 1 from 3 to 4, right? 1 inch. And then corresponding to that is the change in the x, which is 2 weeks. So over 2 weeks, which is 0.5 inches or half an inch per week. Okay, we want to verify that by looking at another point. So here on this graph, you can see that here's another one. This one is at 6 weeks, the height was 6 inches. So it grew from 3 to 6 over the course of 0 to 6 weeks. So that's another rate. Okay. If it's a straight line, we already know that it's growing at a constant rate. But here, let's calculate it. I know that it went from 3 to 6 inches between 0 to 6 weeks. So that's a change of 3 inches over 6 weeks. Which, if you do that again, calculate it, it's half an inch per week, or 0.5. Okay, so we have checked different points, 3 different points. Okay, we are using 3 different points on this graph to come up with this rate of change. Number 4, selling coffee. Okay, total sales over number of pounds. Okay, so that means like how much money did you make according to the number of pounds. Again, 1 pound is $2. 2 pounds is $4. 3 pounds is $6. You can see it crosses here. $6. Okay, so the rate of change. The meaning. So the meaning is basically the amount of money, right, over the number of pounds. And we saw that earlier. It's $2 per pound. Okay, so this means that the coffee costs $2 per pound, right? Because at 2 pounds, I'm gonna write LB for pounds. For 2 pounds, it was $4, right? And it at 3 pounds, it was $6. Okay, LB stands for pounds. So this is the same thing. This is $2 per pound. This is also $2 per pound. Okay. So that's the meaning of this graph. Now we're going to do question number 5. Find the slope of the line in the graph at the right. So we're going to look at this graph. This graph has 2 points. There is 5, -1, and 3, 7. So on this graph, they have found 2 points for us already. Sometimes you will get graphs that don't have any points already labeled for you. You would have to find the points yourself, okay? But whenever you see like the line crossing like somewhere that has a clear intersection, that's a point you can name then easily. So you should pick those points. So here we have one, 3, 7. 3, 7, that's a good one. And then 5, -1, right here. There's another one. So we have points, 3, 7, 5, -1. When you have 2 points and they ask you to find the slope of the line, here's what you do. The slope is represented by the letter m. And the formula for that is y2 minus y1 over x2 minus x1. Meaning that you're going to take the x and the y from the second point. Okay? Now the second point is not necessarily like this point. It can be this point as long as you name it. If you call this your first point, then this is your second point. If you call this your first point, then this is your second point. The important thing is that you use the x and y from the same point, okay? So that means I'm going to use, okay, the x and the y from, say, this point. Okay, so the y here is -1, so I'm going to write -1 here. The x here is 5, so I'm going to write 5 here, okay? And then I'm going to use that to subtract the y of the other point, of the first point. So I'm going to minus, the y here is 7, and I'm going to minus the x from this point, which is 3. Okay, so if you call this point 1, this is point 2. Okay, so that's what these 1, 2 mean. Now I'm going to calculate my slope. -1 minus 7 is -8. 5 minus 3 is 2. And the answer simplified is -4 over 1, or simply -4. That is the slope of this line. Okay, -4. -4. Okay, it's a line that tilts to the left. That goes from, when it goes from left to right, it goes downward. Okay, that's a negative slope. It's a decreasing slope. Okay, you can see that here as well. Okay, on this page here. Rates of change. Okay, when you use your pencil and like follow it from left to right, if it goes up, that's an increasing slope. You will have a positive rate of change or a positive number for your slope. If it goes down, it's decreasing. That's when you have a negative slope. If you have a flat line horizontally, there's no change in the slope. That's called a zero slope. Okay, I think you also can tell that there's something kind of missing from this chart. What about vertical lines, right? You know, lines that go this way, and flat, but what about lines that go vertically up and down? Well, the reason why it's not included here is because vertical lines are not defined. They're called undefined lines. Okay, they're slope, if you will. I'm sorry, they're not undefined lines. Their slopes are undefined. Okay, so that's going to be another question we're going to deal with later on. Okay, let's come back here. Oops, sorry. Let me come back here. Okay. And then we're going to come back to this question. Okay. Lastly, find the slope of the line that passes through the points A, 4, -5, and B, 9, -5. So we are looking at 2 points, A and B. The first point has these coordinates, the second point has these coordinates. Notice that they share the same y. What happens if one of the coordinates is the same? Okay, like here. Both of these have 7 in the y position. How about here? Both of these have 2 in the x position. Okay, we're going to look at them separately. So first, let's look at this kind. using the same equation, m equals to the change in the y over the change in the x, okay? Or in other words, y2 minus y1 over x2 minus x1. We're going to take the, okay, so something minus something, okay? We're going to name this my y, this is my 2.2, this is my 0.1. So I'm going to take the y from this one is -5 and the other one is also -5, and then the x is going to be 9 and 4. Okay, so if I do that, -5 minus -5 is like adding a positive, so it's a -5 and a +5 together. I get 0, and then here's over 5, so this is 5, so the slope is 0. Or just like, because if you look at it, they have, this is one of those lines that's horizontal. It has no slope. A slope would be going up or it goes down. This one has no slope. That's why the slope is 0. So if you look at this one, this will probably end up being the same, right? Because you can see that if you take the y minus the y, you're going to get 0 again. So if you take y2 minus y1, you will get 0 on the top. So it doesn't really matter what's on the bottom. As long as this part is 0, your answer is 0. So for this one, the slope is also 0, or no slope. Okay, so now you can kind of see when the y is the same number here, when the y coordinates are the same, you get 0 slope. But what happens if the x is the same? Okay, let's see. y2 minus y1 over x2 minus x1. So I'm going to take the y's. So I have -1 minus 4. Okay, those are my y's. And then the x's are 2. 2 minus 2. Here, let's see. -1 minus 4 is -5 over 2 minus 2 is 0. So now I have a fraction where I'm dividing by 0. And I don't know if you remember this, but whenever you have a fraction where the denominator is 0, this is called undefined. It's not a real number. It's an undefined number. You cannot have a 0 in the denominator because you cannot divide anything by nothing. Okay, so this is when you have a vertical line. Vertical lines have what's called an undefined slope. Okay, because it's infinite basically. If it's a flat horizontal line, you have a 0 slope or no slope. Okay, but when it comes to vertical lines, we don't call that no slope, we call that undefined slope. Okay, so I hope that helps. These are the 6 problems that are the examples. Your assignment will be from the next page, okay, but they'll be the exact same kind of question. Okay, so for these 4 types of questions,